Part A. The current density in a cylindrical wire of radius r equal to 2 millimeter is uniform across the cross section of the wire. And the current density value J equal to 2 multiply 10 power 5 ampere per meter square. What is the current through the outer portion of the wire between the radial distances r over 2 and r? And its related diagram is given. So you can see the cross-sectional view of the wire. It looks like area of the circle, and it has two radial distance. One is r distance from the center, and from the center to the inner circle, you have r over 2 radial distance. Clear? So you have to apply the formula for the area of the circle. What is the formula for the area of the circle? Which is pi r square. So you have to apply that rule. Now we have to find what should be the current flowing through this radial distance. Between the radial distance, what should be the current? We have to find. And also they clearly mention it is uniform. If it is uniform, then the current density formula J, which is equal to current divided by area. Okay, let's write the given first, and after that we will proceed one by one. So in this question, the radius value is given as 2 millimeter. So in terms of meter, it is 2 multiply 10 power minus 3 meter. And the current density value J is given as 2 multiply 10 power 5 ampere per meter square. Now here the current density is a constant. It's uniform. So we can directly apply the rule J equal to the current over area. So here we are going to find what is the current between this radial distance. So you have to rearrange this equation. If you rearrange this equation, what you'll get? Current, which is equal to the current density multiplied with the area. The current density value already we have here, but the area is very, very important because you have two radial distance. If you see the cross-sectional view of this wire, it looks like area of the circle. So I have to apply the area of the circle for the outer radius, as well as I have to apply the same formula for the inner radius, and then I have to find the difference. So first of all, let's find the area for the outer as well as inner. So I am going to find the final answer for the area. So therefore, the area, which is equal to the outer area minus inner area, right? And we know the formula for the area of the circle, pi r square. So this is the formula for outer radius. And for the inner radius, minus, because we are just going to find the final area, because we are just finding the area, the current between these two radial distance. So outer minus inner. So what is the inner? Pi in place of r square, because the area formula is pi r square. So I have to apply in this place for this radius, I have to substitute r over 2. So if you substitute r over 2 for this radius, what you will get? You will get r square over 4, because you have to square completely. You have to square completely in this place. Clear? Okay, now we have to find what should be the final answer for this area. So better I can just find the area here. So here I'm going to take LCM 4 here. So by that this becomes 4 pi r square minus pi r square. The final answer for the area here is 3 pi r square over 4, right? So I'm going to take this area, I'm going to substitute here. If you substitute, what you'll get? J multiply with 3, this is multiply 3 pi r square over 4. So substitute the value here. If you substitute the value for the current density, current I is equal to current density value is 2 multiply 10 power 5 multiply with 3 pi, and the radius is 2 millimeter. So 2 multiply 10 power minus 3 the whole square divided by 4. So let's see what is the answer for the current. I got the answer here as I equal to 1.88 ampere. So this is the answer for the first part. So here We just find the current, because for the uniform cases, if the current density is uniform, then the current value is 1.88. If the current density is not uniform, then the answer will be different, because you have to find the integration. You have to apply the integration for getting the answer. If the current density is not uniform, then you have to apply the integration rule. So let's we go for the, so I think the first part is very easy. So now we have to go for the second part, and you have to read this question very carefully. Suppose instead that the current density through the cross sections varies with radial distance r as j equal to a r square. So that means in the first part of the question, the concept is the current density is uniform, but in the second part, the current density is not uniform. So we have to apply the rule very carefully. So here, in which the A value is 3 multiplied 10 power 11 ampere per meter power 4, and R is in meters. What now is the current through the same outer portion of the wire? So if the current density is not uniform, so what should be the case? So here, what I'm going to do, first of all, let's write the given. They clearly mention the current density, which is equal to A R square, and the value of A is given here as 3 multiplied 10 power 11 ampere per meter power 4. Now it is not uniform, so I have to take the same rule. What is the rule? The current, which is equal to J multiplied by A. So the same concept, but this is not uniform. Okay, so I have to use the rule I, which is equal to J multiplied by A. So I equal to J multiplied with A. So that means you have to integrate, because it's not uniform, it is different. So I have to integrate J dot J multiply with dA. And what is the outer radius? Outer radius is R, inner radius is R over, I think 2, right? R over 2. Better I can just see this again one more time. Yes, R over 2. So better I have to write R over 2. Okay. Now, in place of this J, I'm going to substitute this value. But what is this area? You have to write the value of the radial distance as a function of R. So if A, which is equal to pi r square, so when you just take the function of equation with respect to function of R, how you can write 2 pi r multiplied by dr, right? So in this place, I have to use this. And in this place of J, I have to substitute, because it's a function of R. The radius is a function of R, right? The current density is a function of R. So in this place, I'm going to take this value and substitute here. And for this dA, I have to take this value. I'm going to substitute this. So what we'll get? Current I, which is equal to integral of R over 2 multi the top R. So in this place, I'm going to write A R square for this J part. For this dA, I have to write 2 pi R multiply. So better I can write small r. Okay, so otherwise you will get confused about this. So better I can modify this, or I can just write as small r. So therefore dA, which is equal to, so it's a function of r, so 2 pi r dr. You already studied calculus. So now what I'm going to do, I'm going to substitute the value of J and dA here. So and then the upper limit is r and the lower limit is r over 2. So in place of J, I'm going to substitute A R square, and in place of dA, I'm going to substitute 2 pi r dr. So now what should be your answer? I'm going to take the constant term outside. So what is the constant term here? A is the constant term, pi is the constant term, and also 2. So 2 pi is the constant term. So I will take it outside. So by that, 2 pi A will come outside, right? And here we have R cube dr, or here R over 2. When you just integrate R cube dr, what you will get, which is R power 4 over 4, you will get, right? So 2 pi A, you will get r power 4 over 4 you will get, and the outer is r, inner is r over 2. Again, this 4 is a constant, so I can take it outside. So 2 pi a over 4. Inside we have only r power 4. So the upper limit is r, the lower limit is r over 2. So in place of this r, I'm going to substitute the value of r and r over 2. So what you will get? So 2 pi a over 4. So here when you apply the upper limit, this becomes caps r power 4 and minus, you'll get r power 4 over 16, right? Because you have to power 4 for all. So now inside I'm going to take 16 as the common LCM. So 2 pi a over 4. Inside the bracket, let's we take 16 as the least common multiple. So here you will get 16 r power 4 minus r power 4. So the top you'll get 15 r power 4. So therefore 2 pi a over 4. Inside the bracket you have 15 r power 4 over 16. So now we are going to substitute the value for a as well as r, because r value already mentioned 2 millimeter, but what is the value of a? So we just go back to see the value of a. What is the value of a? Which is 3 multiply 10 power 11. So 3 multiply 10 power 11. I'm going to substitute that value here. 2 pi multiply 3 multiply 10 power 11 for a value divided by 4. Inside you have 15, and the value of r is 2 millimeters. So 2 multiply 10 power minus 3, the whole power 4 divided by 16. So let's see what is the answer here. So here I got the answer as 7.068 ampere. 7.068 ampere. So if the current density is not uniform, this is the answer. Clear? So you have to integrate. But in the first part, it is uniform, so you no need to integrate. You can directly substitute the formula here. So that's the difference between the first part and the second part. Clear? So please take practice to get the clear idea. Clear? That's it. Thank you.